Welcome to our project for Applied Statistics, Business 7080. This is Learning Engagement 2 by Oluwakemi, Omar, and myself. And we looked at the data we thought was most important to society. And what we came up with was crimes, drugs, and money. So they're different data for different things, but we felt they had the biggest impact on society and our lives. We looked at qualitative data, nominal, quantitative, both continuous and discrete. So starting off with the crime, this was analyzing data from the San Diego hate crime statistics 2016 to 2019. And these are actual hate crimes reported to San Diego Police Department, where hate crime are those criminal acts or attempted acts motivated by hatred on a bunch of different categories. So the interesting thing about this data for me, and one of the reasons that we looked at it, was because there's no numbers, which is easier to do histograms when you have frequencies. This was just basically date, crime, location, some other information. So built a frequency table and realized that a lot of things were combined. So we combined this table by using the COUNTIF in this case to do all kinds of assaults, all kinds of threats. We did that by using a wildcard, and we came up with vandalism and assaults, followed closely by assault as being the #1 crime. Burglaries, batteries, other things, robberies, not so much. Another view of that with the pie chart, again showing assault and vandalism proportionally way higher. We also looked at the weapons used and found that most of the reported hate crimes were actually kind of fist fights, scuffles, where people got in an altercation without weapons. When they looked at weapons, a lot of these weapons that included things like spray paint. What's interesting here is also as the police department were looking at, in addition to things like bottles and golf clubs, we're looking at Facebook as a weapon, email, letters, and spray paint is a weapon. That's interesting how they classified that. We also looked at motivation, and primarily race was a far more reason for people to get into any of these kind of altercations, followed by sexual orientation and then religion. Okay, next we also looked at some drug-related data that Oluwakemi is going to talk about.
Okay, thank you, Professor Eric. So I looked at accidental related drug data. These are accidents that were that happened because the drivers were using one kind of substance or the other. I'll be looking at the specific substance in subsequent presentations. But today we're only going to look at the type of data and the kind of graphs and charts that we have. So first of all, I looked at frequency distribution of drivers by age at the time of accident. And this is an example of an ungrouped data which shows the distribution of the ages over a period of time, which is 2012 to 2012 to 2018. Yeah. So if you notice this data, it doesn't follow the normal distribution. It follows the bimodal distribution. The normal distribution has one single bell. And if you see especially it's showing more on the male category, that's the dotted lines that follow the curve, is showing like a double bell. And this is a simple example of a bimodal distribution showing two peaks among two different ages. So by the time I group this data, it's going to be showing that more accidental drug related events happened when the drivers were just between 20-something years to about 38 years. And by 38 years to about 44 years, we have lesser drivers using drugs and having accidents as a result of drug use.
So and then much more accidents from men and much more accidents from young people and older people, middle-aged people, kind of.
Yes.
Like they have it together.
Yes, but overall, as we can see, more more males had more accidents that are drug related than females. And then one of the key things reflecting in this distribution is that these accidental drug-related accidents keep increasing over the years from 2012 up to 2018. And I'll be looking at maybe contributing factors to this in subsequent presentations. My last graph that I have to present is showing the trend of deaths per quarter over the period of the years that we're looking at, which is 2012 to 2018. And again, this is an example of quantitative data that is looking at time series. Thank you very much. Over to you, Omar.
So now we look at financial data between 2014, 2015 with Omar.
Yeah, thanks, Professor. Thanks, Kimi. So I'm going to start to talk about the summary of the presentation that's in the data giving the financial evaluation for different sectors between 2014 and 2015. So in the correlation test here, we have 5 columns in the data giving the financial evaluation for different sectors. Like I say, between 2014 and 2015, I have conducted a couple of important tests. First of them, I have a test. We have here, I have a test, the relationship between a couple of independent variables, such as the sales price, gross sales, discount, manufacturing prices, and found the hires related. We find here the hires related. So in the second, the variables of profits, we have here analyzes. I conducted a regression analysis between the couples of independent variables, the sales price, gross and sales, and discount. So in the dependent variables, I found the sales price had the highest influence profit. Here we have a unit sold and manufacturing. So here some statistics and histograms were given as well. According to this analysis, we found the main result that I got show that sales price largely influence the profit. So you guys, have you seen the difference of the countries here? The countries and the gross sales, the relations between the price, how's it going up, and like I said, some statistics and histograms were given as well. That's all.
Okay, thank you very much.
Mm-hmm. Thank you, Professor.
Thank you, Professor Eric.
So how we